Hi, welcome everyone. This is our fourth installment of the Ohio Concrete Fall webinar series. We're having a dual panelist discussion today on the perfect concrete parking lot and then current ODOT specification changes. Real quick, we're going to take a break on the fifth one. Our next meeting will be December 3rd with Dan DeGraff from the Michigan Concrete Association, and then an additional panel conversation with additional specifications and changes to the materials in the state of Ohio. So I think we're going to have a real good presentation today, and then in 2 weeks we'll be back again for the fifth one. Today we're going to start out with Dan King from Perrin Asphalt and Concrete. They're a long-established business in the Akron area, and Dan is the operations manager for Perrin on the concrete side. And he's been doing this for a long time, and he has a lot of thoughts on how to put together a perfect parking lot from design to construction. So with that, I'm going to pass it over to him. We will do Q&A in between the two presentations. So if you have any questions, please use the Q&A box, not the chat box. And then he's probably got a 15-minute presentation. We'll do some Q&A and then head over to Dan Miller from the DOT and material specifications. So thanks for participating. I hope you enjoy the seminar. Thanks.
Okay, hello, this is Dan King with Perrin Asphalt and Concrete. Thanks for tuning in today for the webinar. And we're going to discuss...
No video, sorry, video. They're not seeing you.
There is no video. Okay.
Only that.
Okay.
Let them know.
We're having technical difficulties here, and it's been a little screwy here the last 10 minutes trying to get set up for this presentation. The picture you're seeing here is our guys finishing a parking lot at Wadsworth Art-Rite Stadium at Wadsworth High School. This was a concrete parking lot, probably 250 cubic yards, and so a lot of the pictures today in my slide pertain to this installation. Oop. Wanted to talk briefly about aggregate base. And my take on aggregate base is we recommend a minimum of 6 inches under most applications. We recycle aggregate here at our facility, and so we promote the use of recycled aggregate. We actually have installed over 100,000 tons of recycled aggregate under our pavements every year. Never one issue with warranties or failure from the aggregate base that we use. These two young guys here in the picture are fourth generation Perrins, and they'll be my boss if I don't retire first. Under drains in parking lots are huge. We're a firm believer in using under drains to keep the soils dry and the stone base dry. And at a minimum, we'd like to see in design at least finger drains coming out of all structures, all drainage structures. It really helps after a rain event during construction, and the site dries a lot faster, and after the concrete or asphalt pavement's installed, it really keeps the water from pooling around the drainage structures, and keeps the stone base dry, free of water. So once we hit these freezing temperatures in the winter, the pavement doesn't heave and shift around because of the freeze-thaw cycle. So while you're designing parking lots, please keep in mind to include some under drains and under slab drainage. Talk a little bit about reinforcement. As a contractor, we try to, when we can, not to use wire mesh and rebar. Several reasons. typically it's installed incorrectly because many contractors fail to use the chairs and slab bolsters to keep it in the right elevation in the slab or pavement assembly. It also adds cost during construction. When we use steel, we often have to pump the concrete into place, which adds additional cost. You have the time installing the steel, and the steel itself, working with the steel while installing is dangerous. Unloading it's dangerous. It gets bent up and deformed while we're moving it around the job site. We have problems with steel sticking out of the slab because it's bent. And then the guys placing the concrete, they trip on it. They trip on the mesh, they trip on the rebar, and it causes a lot of injuries. So for safety reasons, we have to be very careful working with a wire mesh and rebar. We promote the use of fibers when we can and have really good success with macro fibers. We've used macro fibers in some really heavy duty applications, and it's been really, we have incredible results with macro fibers.
Okay, it sounds like we may have lost connection. We'll try to get it back quickly.
In your designs. Here's a picture of a parking lot that we installed last year for the Cauga Valley National Park. It's actually an RV parking lot. And as you can see, we're utilizing a pump truck. We had actually used 78-pound mesh on this project, chaired up, I believe, 6 inches into the slab. That was an 8-inch thick slab. There's one of our guys installing mesh. You see the tool right next to him is a rebar tying gun. It comes with a spool wire, and we try to tie our mesh to the chairs and also to at the overlaps when we install mesh to keep it from shifting around during concrete installation. Talk a little bit more about design and pavement grades. We are seeing increasing parking lots and roads increasingly designed with not enough slope to facilitate drainage. Anytime you can get more than 2% slope, minimum 2% slope is what we need. We're imperfect as installers, and we have bull float marks and knee board marks, imperfections in the surface as we're finishing, and less than 2%. It makes it really hard for us not to have puddles and bird baths. One of the most important things that have come about in recent years are the ADA and path of travel requirements. This year, I would venture to say we've done 25 to 30 retro repairs, retrofits to existing parking lots because the ADA parking spaces and the path of travel entering the building did not meet code, and there are litigious attorneys now running around at businesses with the levels and trying to find when there's a business out of compliance. So not only have we completed 25, 30, maybe 40 different retrofits and repairs, we've also had many, not many, but several mistakes that we've made on jobs where we didn't meet the ADA requirements for slope in the parking areas. And most of those are asphalt jobs. It's really hard for an asphalt paver to maintain the tolerances in the ADA area. So we typically, if we design the parking lot ourselves, and even if we don't design it, we typically substitute the parking area. Instead of asphalt in the ADA area, we install concrete. It's easier to hold the standards that you need to hold in the elevations, pouring concrete in those areas, straight edging from form to form, having time to set up your forms and double check the percent of slope in those areas. It's really important as designers, for us as contractors, it's really important that the designers include a clear drawing, detail the handicap ADA areas, show us the slopes, and really clearly define those. This is a good example in this slide of a well-defined ADA area. So please, when you're designing parking lots, or if you have a project that you're working on and it's not clear, get clarification from the designer, get a plan, a detail. This drawing here is excellent. It leaves little room for error. One of the things I wanted to talk about today, it helps save costs, it improves efficiency and time while installing a parking lot. If curbs are designed or required or desired, we really like to see in concrete parking lot the use of interval curbs. It helps reduce construction costs. You're only bringing one crew in. You're installing the curbs at the same time that you're installing the rest of the pavement. It really helps with time, costs. Talk a little bit about construction. As we start a project, we typically have it surveyed, and once we have it surveyed, we excavate the site to subgrade depth. And once it's excavated to subgrade depth, we compact the soil and always engage a third-party testing inspection agency to come out and evaluate a proof roll that we perform with a truck, a tandem axle truck, 60,000 pounds gross vehicle weight. For the proof roll, we roll it back and forth across the subgrade in a slow manner and watch for deflection in the soils. And if it's unsuitable, then we defer to the third-party testing agency for recommendations on how we can remediate the soil. I always like to have the owner on site or an owner's representative during the proof roll as well. That they can witness for themselves if the soils aren't up to the standards we need, and they understand then why there's additional costs involved in the project to remediate the soils. But we always provide a proposal for the subgrade remediation and have the owner approve prior to starting any of the additional work. And most of the failures that we see in asphalt and concrete parking lots that fail prematurely, I would say 75% of the time they fail because the base, the sub base underneath and the subgrade just isn't suitable to support the loads of the pavement that are required in the pavement. And it just reflects through the pavement, it cracks up. And so we firmly believe in proof rolling, have to have a stable subgrade. And that's, I think, the key to starting a concrete parking lot with the excavation is to make sure that you start on firm soils. There's a picture of a proof roll. We typically load a tandem axle truck and walk along and with a can of paint, we'll paint the areas that need remediated. and identify them, paint them right on the ground. One of the things that helps with our company be so efficient with parking lots is our forming and prep. We put a lot of time and energy into the work before the crew shows up to install the concrete. We always double check our elevations, even double check the surveyor's elevations and make sure we have enough slope for proper drainage. Again, we check the ADA areas and the path of travel time and time again. To tell you how hard it is to meet that tolerance, I typically set our sidewalks up for 1.5% cross slope in the path of travel, and we set the forms at 1.5%. Recently I was on a job and I was checking behind the guy bull floating the sidewalk behind the straight edge, and just the simple act of bull floating the slab was enough to take it out of tolerance. And even though the forms were 1.5%, the dip in the bull float brought the cross slope to 2.25%. So it's really important to check, double check, triple check the forms. We provide plenty of grade hubs for screeding as we're forming. We space those roughly 16 foot apart. They're just rebar grade hubs that we pound down, and the top of the rebar will be top of the concrete elevation. So when the guys come to install the concrete, they have an elevation to hit, and then they pound the rebar down once we pull our screed through. We use dowel sleeves whenever possible at construction joints. They allow us, they allow for the proper alignment of the dowels in the slab, but more importantly, we're able to strip those forms as we're pouring and keep installing concrete that day, so we can keep a continuous pour going. There's a picture of one of the types of dowel sleeves we use. You can see the dowel sleeves actually stay in the pour once we strip the form. The expansion joint that's showing there looks wavy, but it's actually recycled rubber. We like to use recycled rubber expansion joint. It doesn't rot away, leave a void, big crack in the parking lot. Another picture, the base screws to the wood forms. And then again, the dowel sleeve itself stays in the concrete. These are called diamond dowels. We also use those, same concept. Going back to the grade hubs, we like to space those out around 16 feet apart so that we can establish screed guides. We use a 3D laser screed often when we're installing parking lots, and we actually put a grade hub at all elevation breaks, peaks and valleys. I would say 25 foot apart when we use a laser screed. And the laser screeds have a total station system. So they actually go out on site, set up their laser, and then go around and shoot the top of all the rebar grade hubs that we pound in the ground. And then once that data is entered into their computer on the laser screed, we simply remove the grade hubs. You can see in this picture, if you look closely at where the pump boom is overstretched over top of the wire mesh, you see little dots that are painted orange, or orange paint marks on the pavement. And that's our rebar grid. That's how we control elevation. Make sure we hit our elevation right where we need to hit it. one of the things that, looking back on this picture, well, that's not a good picture. I'll have to find another one. But one of the things that, one of the challenges that, as we're installing a concrete parking lot, is that we need to keep the widths to, I would say, no greater than 60 feet. That allows us to place the concrete and keep from getting cold joints. It also allows us to finish the concrete. Any wider than 60 feet, it becomes really tough to get a broom finish on the concrete. And we actually use a rope broom for finishing the concrete. And we'll have two guys standing outside of the either edge of the pour, edging, bull floating, and pulling the rope broom across. Here's a picture of a rope broom. I don't know how wide that area was there, but I'm assuming it was a fairly wide area that you couldn't get with a broom on poles. Communication with the ready mix supplier is one of the most key factors for a successful installation. It's actually key for our operations on a day-to-day basis. We're in constant communication with the ready mix producers every day, multiple times a day. When you're planning a concrete pour, they need many days ahead, at least a week ahead of time. They need to know that pour is going to be happening and what day the pour is going to be happening. They need to know the quantity that you need that day, and they need to know your production rate. For instance, if we're using a laser screed, I typically will place 90 to 100 cubic yards an hour. It's hard for a plant that typically produces 1,000 cubic yards a day to keep up. It almost takes every truck that they have, depending on the proximity to the pour, how far they're trucking it. So you really, ahead of time, it's really important that we communicate with our ready mix producers. Make sure that you have enough guys on the site to keep the concrete flowing, keep it down. No cold joints. Having too many trucks on this, if you don't have enough trucks on the site, you're waiting for trucks. It's very easy to get cold joints in a parking lot. And having too many trucks on the site, you end up with hot loads or sending trucks back unused. So it's really important that you know your production rates, communicate that with the ready mix producer, and know your timing. Also, prior to starting the job, and as you're communicating, I usually send a map of the area for the dispatcher along with verbal directions so that they can let all the truck drivers know exactly where to go on the job, where to stage themselves, and where to wash out. This is that small parking lot that we did over at Wadsworth Artwright Stadium. I just wanted to kind of show everyone how you can use the speed dials and forms and expansion joint to sequence a pour so that it can be completed in one day. So if you look at this, you can see the form lines where we installed forms with speed dials and expansion joint. And we started at 1 and placed that concrete first. And then we moved to area 2 and worked from the bulkhead down to the existing parking lot. And by the time we jumped up to area 3, we were able to walk on 1 so that we could pull the rope broom across. So we just stripped our forms and went ahead and walked down the first slab that we poured, and we were able to broom finish the concrete with no problem. Again, this was a smaller pour, smaller installation. It might have been a 220 to 250 cubic yard parking lot, but it took us approximately 4 to 6 hours to install, and we did it all by hand using vibrating screeds, and went really smooth. You can see the form line for area 2 there.
I can use your mouse. I don't know if that works.
Oh, yeah. There you can see the form line for area 2 there. We were able to start back here and work our way back down, and by the time we got to here, strip that form and insert our dowels. We like to provide a really nice washout area. A lot of contractors don't think about this beforehand. It's really important to identify that area. You want to be able to get 2 trucks up to your washout at the same time. The quicker we get those trucks back on the road, the quicker they're back on your job with concrete. So it's very important to have an efficient washout area and keep those trucks moving. You want to sequence the installation of the pour to allow for continuous installation. Again, we recommend 60 feet wide. We utilize super plasticizer on a daily basis to achieve workable slumps in lieu of adding additional water. If you're specifying projects, I recommend maybe even adding that to your specification, the use of super plasticizer to achieve slumps. There's a nice picture of a washout pit. We actually provide and rent these to other contractors in Northeast Ohio. This particular washout pit has ramps on the front of it that fold out, and we can actually back the pump truck up over top and able to wash the hopper out in this washout pit. You can get 3 or 4 trucks up to this at a time. These are portable. We deliver those on a roll-off truck, just like a roll-off dumpster. Manpower. The worst thing you can possibly do when you're doing a large concrete install that leads to some of the worst days of your life is shorthanding your labor. You always want to plan for the worst case scenario and have your labor scheduled accordingly. You want to we love to cure right behind our brooming operation, and we make sure that we provide adequate coverage of the cure. It's a cheap insurance, very important for the longevity of the concrete. We always use an early entry saw when we can in our pavement, and we get on it and start cutting it just as soon as we can walk on it. Waiting to stripe is sometimes hard to do because owners want immediate possession, but we encourage waiting as long as possible to stripe the concrete, allow it to cure and the moisture to dissipate from the slab so that the paint doesn't peel and flake and prematurely. That's one of the issues that we actually see in concrete parking lots a lot, that they need they're often striped way too soon after the concrete's placed. As when Bob introduced me, he said our company is Perrin Asphalt and Concrete, and we do we do equal amounts of asphalt and concrete, and oftentimes I'm asked, why would you go with a concrete parking lot and in lieu of asphalt? Is an asphalt cheaper? Not necessarily. I would like to think that any lot 5,000 square feet or less is going to be definitely cheaper to do in concrete than it is asphalt. The cost of an asphalt paving equipment crew is probably around $1 million. The cost of equipment that we need to utilize to install a concrete parking lot is less than 50,000. Big difference in cost of equipment, overhead costs. Parking lots, we're going to talk about integral curbs again. Parking lots that are designed to have curbs. If you can do a concrete parking lot with integral curbs, that saves not only grading time, it also saves time with the installation of the parking lot. Typically, if it's an asphalt parking lot and we install a 6x18 curb, you achieve subgrade, you install the stone for say your 6-inch concrete, then you have to go back and excavate a slot to get that, or 6 inches of asphalt, I'm sorry. So you would have to go back and excavate a slot for the installation of the curb. Then we'd bring a crew in and install the curb. Once the curb's installed, you'd have to bring another crew back out, a grading crew, to backfill the curb and the slot where the curb was, and then touch up and fine grade the parking lot. Then you have to bring in another crew to install the asphalt. So you can save a lot of money and a lot of time on smaller parking lots by designing the parking lots as concrete parking lots with integral curbs. Concrete's virtually maintenance free. We all know that it has a greater life cycle. Asphalt parking lots require maintenance, crack filling, seal coating, restriping. Asphalt parking lots are hot in the summer. They really produce a tremendous heat island effect. So a concrete parking lot is actually decreases your cooling costs for the buildings, and the concrete parking lots require less site lighting because they're brighter. I think that's about all I have. Just touching base back on everything. As most of you guys are designers, we want to really focus on elevations and give us room for error as contractors. Please keep the slopes 2% and greater. ADA specifically, detail out the ADA areas and show us the path of travel. If it's an asphalt parking lot, area in concrete, even in all asphalt parking lots. And Bob's taking a picture of me for some reason here. I guess Wayne's going to ask some questions now.
Yes, Wayne will do Q&A.
Okay.
So he'll jump in.
Yeah, I'm going to jump in here with the technical difficulties we're having. I'll go ahead and ask the questions here and introduce our next speaker. I guess, let me see here. We just had one come in. Can you provide info on typical lifespan of a concrete versus asphalt parking lot?
For us, we see around 30 years concrete, asphalt 10 years. You're typically looking after 10 years at resurfacing, 10 to 15 years on the surface course of the asphalt.
Okay. Next question. It didn't come in on a Q&A, but I had a few questions that came in earlier. When you talk about the subgrade, there's a lot of variance out there with some people will believe, and these are highly educated people in the concrete industry with a lot of knowledge, and they believe you can put it right on the sub base, the concrete, and then others want aggregate base before they put the concrete down. And to be honest, that's typically what we recommend at Ohio Concrete. And you said 6 inches, and that's probably more than what you see recommended in most cases from the concrete side. What are your thoughts on that, going from putting the concrete just on the dirt to all the way up to why do you think you need as much as 6 inches?
I can tell you from our experience, I do a program. We do a lot of programs, road maintenance programs. We'll take contracts in various cities around northeast Ohio, and a lot of the pavements in the I think it was in this concrete pavements they were installed in the 80s. We're excavating those out and replacing them, and they were installed right on soil, right on the subgrade soil, and I think the more stone the better, in my opinion. It allows for drainage under the slab, and it's also really hard to grade with a dozer and keep your quantities of concrete installed. It's hard to keep your quantities when you're taking a bulldozer, depending on the soil type. If it's clay, sometimes it's really hard to grade that to a really tight spec, especially if you're trying to get within a ½ inch plus or minus on your subgrade. So in our opinion, we try to use stone wherever we can, and as much.
Just to follow up on that, if it went from say 4 inches of stone to 6 inches of stone, do you think that's going to make a big difference in durability or longevity?
It probably, I think it does. And I also think that 4 inches of stone is harder to install than 6 inches of stone. That's what my operators tell me. And I'm not exactly sure why, but they seem to get better production when we go to 6 inches.
Okay, got one last question, then we're going to move on to Dan Miller. How do you control the fines on recycled aggregates?
That's a good question. We have an incredible screening process. Our quality control on our recycled aggregate is something I've never seen in another recycling yard, and I've been into many. We actually have a tower when you pull in, and we inspect every load before it comes into our facility, and make sure that there's no organics in it. It's really amazing the pains that we take and the expense that we go through to make sure that we're putting out a good recycled product. And there's no regulation that I know of, or very little regulation in the recycled industry. And I think that's part of the reason why recycled aggregates have sometimes they're frowned upon, and because there's contractors that are mixing dirt with the concrete, organics, and they're just trying to make as much volume as they can at the cheapest. And those recycled aggregates, when they're mixed with dirt, they get real spongy and they don't take water well. We control the fines with a screening process. Getting back to the fines, so that's how we control that.
Okay, two more questions that came in, and if any come in after this, we're gonna just have to move on, and maybe you can answer them and we can put out an email. I'll ask you the quick one. I think first, what are the max % slope requirements for ADA pathways in parking lots?
Max for the pathway, I believe, is 2%.
2%. Okay. And the last question, you had mentioned stone for drainage. ODOT 304 is well graded, does not permit water to migrate much better than the soil. Any
True.
logic behind using 304 versus 57s or an open graded stone?
We use 304 for everything under our pavement to keep the water out.
Okay.
So that's what we recommend. We recommend 304. Water still finds its way in there, though. That's why I'm a big proponent of under drains.
All right, Dan, thank you very much. We appreciate
Thanks,
you taking
Wayne.
the time to do that. And now we're going to go ahead and move on to Mr. Dan Miller with ODOT, the cement and concrete engineer. He has been great to work with here over the years, and I think his screen will be coming up here in a moment. And Dan will Mr. Dan Miller, we'll go ahead and get started.
Great, thanks, Wayne. Appreciate everybody here today for the webinar. Good presentation from Mr. Dan King there for payments. For me today, what I'm going to touch on is ODOT specifications. Let me share that. Sorry about that. Wasn't fully sharing. Let's see. Okay. So for the specifications that I'll touch on today is our 451, 452, which is concrete pavement. I'll touch on aspects within 455, which is our quality control, quality assurance section. Kind of got a few key details that I always like to touch on whenever I'm presenting a webinar or giving a talk of any sort of nature. It's beneficial for everyone to see. Touch on some items within item 499, which is our ready-mix concrete, along with supplement 1126, which goes into the more important portion and aspects for the ready-mix supplier on how to obtain a JMF approval and what's required in there. And mainly for this topic, I'm going to touch on the self-consolidated concrete aspects there. Touch again on 499.05.D, the new spec for volumetric trucks and what we're going to allow with those. And then lastly, 705.29 for a spec item for fibers in concrete. So for 451 and 452, we do have the new mix designation, which is the QC1P. It does still have the 4,000 PSI compressive strength parameter with 2,000 or less coulombs of permeability using the AASHTO T277 test. In doing supplement 1126, this would require an AASHTO accredited lab and the ACI 301 over design of 5,200 PSI. We did also take for ready mix suppliers, if they had a QC1 mix that was previously approved, and it was found that the stone met the 70313 requirements for freeze thaw from our aggregate section in the 1068 program. For that, we did grandfather those mixes and give and send on to the ready mix supplier a JMF number that tended to coincide with what they had. There may have been some slight variations in there, but we did try and keep, if it was 019A, then we have 1P9A in most situations. Now, that may not always be the case, but we did try and keep a same designation for the ready mix supplier and for ourselves to make sure we can track those JMFs accordingly and help everybody along and try and keep order with their mix designs that they submit throughout the year or years as it may be. The hyperpave requirement, we did remove that from the specification. That came about due to corresponding with other states and with myself being the National Concrete Consortium chair. The National Concrete Consortium is a group of 30 states, the Illinois Tollway, and the Transportation Cabinet of Manitoba, Canada. And we meet biannually when we can, of course, and have discussions on structures and pavements. And I put out a survey to them, and the responses back to me was that hyperpave is not required by any state specifications. It is a tool that the contractors can use to determine their early entry for sawing applications. It is still recommended for use as a QC tool in the field, but again, it is not a spec requirement as it was in the past. I know we were finding issues a few years ago where contractors were not able to get the updates. The NOAA weather report was not built in there anymore. We had lost that connection, and Internet and Microsoft 10 kind of killed some of that in some aspects. So we've kind of shied away from that, but it is still there for the contractors to use. I believe they have updated the software to make hyperpave work a little bit better now and have fixed some of the broken connections. I know it did also include slag aggregates and also slag cement as well in the program, as it was not there previously. With regards to dowel baskets in the specification, the shipping wires was the main point of contention, and it was felt that when we snip those and take those out of the way, it makes the baskets weak, and they're not as in good alignment. We don't get good alignment anymore when we cut the shipping wires. So it was determined that we can leave the shipping wires in place. So that is a change to the specification. However, both as contractor and owner, we still need to take our ownership to review the placement of the baskets and make sure that they have been firmly placed and aligned along the grade, make sure they're level, make sure they're parallel to the alignment and direction of travel for the pavement. That way we can ensure good joints in the future and for long term. So that way we can meet our design life criteria and not have any issues. For joints in concrete pavement, this is where you'll find a large change. I did pull this slide or these screen clippings from the spec where this was updated, and we have condensed the joint section into one grouping. So we don't have just transverse joints, longitudinal joints, and construction and contraction joints. Everything has been condensed now into one section in 45109. And then the other aspects, there are still some minor details that were there, but instead of repeating the same language over and over again about what types of saws to use and what depths we need to cut to, we've brought that into one section. So that way it makes it easier to read the specification, and we can keep going throughout the spec and capture different details. And for those that when we're printing the book, we're possibly making less pages, and sometimes they like that. For CMS item 455, it does require a project-specific quality control plan. We do have to have an AASHTO accredited laboratory on site performing the work, and they do need to make sure and maintain their status with AASHTO. That can be checked at the AASHTO resource webpage, and you can search around and find and make sure your lab is accredited that you're using, or if you are a laboratory and have questions about your accreditation, you can check that there as well. For ODOT projects, we do require ACI field and ACI strength test certified technicians on site and at the lab. So in the lab, you'll have your strength test certified technician. They are the one responsible for testing the cylinders at 28 days. And then the ACI field technician will be doing the fresh properties on site. One adage with this is currently in our specs, we do still require ASTM C143, the slump test. We highly recommend not going with the eyeball approach, if you will. If we're out in the field and folks are deciding, yeah, I'm just going to eyeball this slump today, eyeball that as a 3-inch slump. That is honestly the best way to falsify something if we record that value. So I would recommend not doing that, as that may cause issues down the line that may involve the Federal Highway Administration coming out on the job site to do some checks and may lead to further actions if we do find a lot of eyeballing, if you will. So please do be mindful that the slump test is still required as a test to be run by the contractor and also by the department. Item 455 does cover that with the plus or minus 1% and plus or minus 1 inch for slump and air for that check in there. So we do still check that. So do be mindful of that. Delivery of cylinders in a timely manner. We as a department do take the responsibility to provide paperwork and make sure that our cylinders are labeled accordingly. And then it is the responsibility of the QC to deliver the labs to the respective district laboratory. We've had some recently here at central office, we end up getting a set or two of cylinders, but we are not the representative lab for District 6. The District 6 lab is in Delaware County, and cylinders need to go to their location. While cylinders are stored on site for 455, it does require the contractor or the contractor's lab to provide that mechanism for curing and make sure they're tracking temperatures with high-low thermometers as best they can. Okay, so that needs to be in the quality control plan as to how the QC lab is going to maintain those items and keep track of temperature logs and how they're monitoring temperature within those curing environments. Okay. For non-QC QA ODOT jobs, it is the responsibility of the contractor to provide the means necessary for us to cure the cylinders. Also, we want to make sure and maintain good records, make sure we have good daily diaries as QC Lab and even as ODOT folks, as we're required to by our own requirements and rules. Take any photographs if you see the need to, or any other good items or tactics that you see as good recommendations for project tracking and progress, and good material records and contract records. CMS item 499, we did have for the spec book 19, the QC1P update. We did also add our self-consolidating requirements. For the SCC, it is our 4,500 PSI, so it is similar to the QC2. 1,500 coulombs or less for permeability. The main item for the aggregates, however, is it does not have to be well graded. It can, but if you need a tighter tolerance for reinforcing steel, or there's a decorative feature such as trees or birds, anything such as that, or gentlemen riding in a canoe or ladies in a canoe, whatever we can dream up with concrete with SCC, we can make it happen. And we want to follow the guidance of ACI 237R for SCC requirements. And then we also have different requirements in 499 for the slump flow. And we have 3 different classes for the slump flow that can be called out by designers. It can be in plan notes, but hopefully the designers can start to call these out with the different classes. And there are some avenues that I've been addressed from others in construction that we need to really tie this into the spec a little bit more and get it tied into our 511 spec and other areas as where to use SCC and get the most benefit out of it. Again, I think it's mainly for our decorative areas, for drilled shafts, and even in situations to where we have tight reinforcement tolerances that we need it. It's currently used in precast, pre-stress, and concrete pipe industry. They are using those quite regularly with great success. So hopefully we can start using it a little bit more in our day-to-day concrete placements. For supplement 1126, we do have some different requirements that go along with the SCC mix design. And based on each slump flow, we do recommend having 3 different submittals. So if you want a class 1, a class 2, and a class 3 within your suite of mixes that you can provide to the department, we do ask for testing to be performed at each of those levels for the visual stability index, the J-ring, and also the static segregation test. We do recommend that we understand that it's admixtures that are changing in here. The recommendation is to go to the class 3 and do your permeability and strength testing based on that. And then we can back down from those, and the testing lab can provide data for the other 2 slump flow classes and then submit that data. Make sure to include in your test reports the aggregates that are being used, the cement that was used, the batch weights that are being used. Okay, we need to have that information. We've been seeing some submittals lately where we're completely missing everything. All we're getting is strength test and permeability test data, and that's not enough to give us anything to go off of to make sure we're verifying what materials went into that testing at the lab for the lab testing that was performed. So do be mindful of that. Ready mix suppliers, when you're asking your testing lab, whoever that may be, to perform testing for you, to make sure and provide all the information that you've supplied to them possibly with regards to aggregates, cementitious materials, admixtures, things of that nature. And then they can give you that back in the report with the chosen maximum water to cement ratio that you desire, along with the photographs of the J-ring slump flow with your VSI, the visual stability index. We're looking for a 0 to 1 there, and I'll show a picture of that here in a second. But make sure we have all the information that we need with regards to the mix design submittal, and then that can be submitted to our email address. So for SCC, when we're in the field, typically what we're going to do is the ASTM C1611 slump flow with the inverted slump cone. Again, we're looking for either a highly stable or a stable mix. We do not want to see an unstable or a highly unstable mix, as those would not be acceptable on the job site. And we would need to either make adjustments or we're going to reject that load of SCC concrete due to it being too wet and we've got too much bleed going on within that mix. C1621 is the J-ring test. We do want to make sure and perform that test as well for the passing ability and make sure it meets those parameters. And then lastly, the C1712, which is the penetration test. So you use the small apparatus and basically prior to pulling your slump flow or even doing a completely separate test, you can stick the apparatus on top, set it gently on the concrete, let it stabilize, and then read the measurements off of the little gauge here and determine your penetration. Another test that we have that has the ability to be used, and precast and pre-stress folks are required to use this and need to look at this again for ready-mix concrete, but C1610, the static segregation column, it does seem to be a cumbersome test from doing the ACI SCC certification program and trying to perform that test, but it does give a good idea of your percent segregation between the top and the bottom of the mix. So it is a good mix verification tool. We would not see this test, the 1610. We're not going to see that performed on the job site ever. I can say that wholeheartedly. But we will ask for the slump flow test. And at this point, that would be the only one. We haven't gone to the J-ring test in the field at this point. We've used it as a mix submittal tool for the time being. Other updates within 499, again, we want to make sure not exceed our water to cementitious or water to powder ratio at any time. Aggregate adjustments, if we're within the 100 pounds, we don't have to, no approval is needed from the engineer. It's still good to let them know you made an adjustment. If you're greater than 100 pounds, then you must provide a compass report and notify the engineer prior to use of that concrete that you need to make the change. Okay? So do be mindful of that. We've had some times where we start seeing mixes and a lot of changes have been made, but there was no approval from the engineer prior to. Some of that may be based on doing a slip form mix or a slip form barrier, which in some avenues I've even recommended that we, have a separate mix design to do a little bit better other than pull out water, slug in sand, here's my new slip form barrier mix. So be mindful of that. If you feel you need a separate mix and it's going to be more durable for everybody, then a new mix may be beneficial to have that testing for a slip form application. Addition of non-chloride accelerator. We're kind of in that season right now where it may be possible to use that, but again, that isn't the responsibility of the engineer to give prior approval prior to use of it on site. Okay, so be mindful of that. I do get calls every now and again asking me, hey, can we do this? And I say, yeah, it's up to project engineer and what kind of temperatures do we have? Are we 65 degrees a day and going down to 20 degrees at night? Yeah, it's probably going to be beneficial to have it in there. But again, that is up to the project engineer to make that decision. If we're making additions on site, make sure we're within the 90-minute time limit and the truck's not showing up at that 90th minute. And don't exceed the water to cement or water to powder ratio. In addition to the spec in 499.04, letter H, with regards to slump loss, we can add F or G admixtures. And even in that, there is a possibility to add water, but we do want to be cautious of that. And the contractor and ready-mix supplier should be able to dial this in such that we're not having large occurrences of water needing to be added if we have slump loss within prior to placement or even during placement. But again, if we do have that issue and we have to add a little bit of water, it's beneficial to have to notify the engineer, and we're going to have to repull testing. So we'd have to pull a sample again and run slump in there to verify that. So it's beneficial to not have to add water when we're backed up to the pump and unloading, but we understand that may happen. Hopefully we can dial that in and not have to worry about those issues. Again, our rule of thumb is we can make 2 attempts to adjust air on site. If we can't bring it in the spec, then most likely we'll reject the truck, and then again, making sure we're within our 90-minute time limit. new animal, volumetric trucks. I mean, they're not real new. We've used them on latex overlays, seen them in other avenues. Okay. So we did add them to the spec. They had been used in 847 and 848 applications using a latex overlay. Low strength mortar backfill seems to be a good avenue or a place for these. Manhole and monument adjustments, and even miscellaneous and fast set mixes would be beneficial for volumetric trucks. 499.0405D is the spec where this lies. I'm missing the 5 up there, I see. I'm sorry about that. The mixer should conform to ASTM C685 with the sections listed there in the slide. We do need a process control plan and a product quality control plan from the volumetric truck outfit that's supplying the concrete for material handling and storage, et cetera, as to how they're going to handle it. That may be an all the time deal if you're in close proximity to where the trucks are normally parked, but if you're far enough away to where you have to use a different staging area, then that may change on a project by project basis. So do keep that in mind. When will the truck be required to be calibrated? Okay, typically it's going to be a per project item unless you're always using the same materials. Okay. Moisture adjustments still need to be followed in accordance with 49906, and each truck will have to have the ODOT tags that we've been putting on, basically like a little earring, I'll call it, where we've been using truck container tags with a serial number. So each truck will have a serial number that will coincide with it when delivering concrete to an ODOT job. Batching tolerances are slightly different than our regular batching tolerances for ready mix concrete. We can see those there. So there's 0 to +4 for our cementitious materials. Aggregates is ±2. Water stays ±1, and chemical admixture stays at ±3. Okay. And then lastly, our 705.29, we did add macro synthetic fibers for concrete. This was added in the July update of the ODOT CMS. We tried not to reinvent the wheel, so we basically went with following what Illinois Tollway, Illinois DOT, and the Indiana DOT have started. And we did follow their same guidance. So in 705.29, you'll find the requirements from ASTM C1116 and ASTM D7508, with our exceptions listed for the aspect ratio, tensile breaking strength, modulus of elasticity, the length of the fibers, and then our dosage rate. So the dosage rate will be a minimum of 4 pounds per cubic yard. And then we'll test the synthetic fibers in accordance with ASTM C1609 and C1579, making sure to utilize an AASHTO accredited laboratory for Portland cement and concrete materials, and make sure we meet the requirements within the table for the hardened concrete. So we're looking for our equivalent flexural strength ratio to be a minimum of 25%. And we need a minimum of 600 PSI flex at first crack. Okay, so these are the parameters that we want to verify with the fibers, and then the fiber manufacturers can submit and will furnish according to the department's QPL. So from there, you can go to the QPL website. I did add, as you can see below, we've had it added to the QPL. Amir Tarani, who's in my lab, he is responsible for the QPL list. And 705.29 is the fibers. That is where the listing of fibers is. And then the fibers for concrete title, that is where you find the guidance on how to submit and what documentation is required to submit the fibers for approval. And with that, I will take any questions.
All right, Dan, great. Thank you. Nice job. Got a few questions that came in. First one, what does ODOT think of recycled concrete for major repaving jobs?
So kind of a loaded question. I think it's something that we can do. We do have a supplement for that. Supplement 1117 does handle testing parameters and protocol currently when doing recycled concrete as aggregate for a concrete pavement or any other sort of recycled concrete, and it can be done. With regards to recycled 304, I know we had done some previous research where we found tufa in the under drains, and based on that research, there had been a moratorium on recycled concrete as 304. That being said, I think that's something that could be revisited with, I think that would be a partnership process between Ohio Concrete, ODOT, and the aggregate industry with OAIMA to meet and discuss what can be done there. How could we do that? I think there is a market for that. I think there's a way that we could bring that back, or industry can bring that back around, and maybe we can change the spec a little bit or do more due diligence to determine where we need to go and what we can do. As I've kind of stated before, I know we've had a recent project in District 6 where I thought we could have done alternate with what happened out there, but I was kind of just left out of that and kind of told no, we weren't going that route. So some concerns that I had there, I thought we could have really used the concrete pavement that was out there and recycled it and put it back down with proper diligence, proper testing, but it was not selected by the district to go that way.
Okay, next question. Who is responsible for maintaining the cure box curing temperatures between 60 to 80 degrees during cold weather operations?
Well, that's a loaded question. That would be for a non-QC QA project, that would be the contractor's responsibility. If it is a with QC QA project, that would be an agreement between the private testing lab and the contractor as to who's going to perform that, who's going to maintain that, and determine their means and methods as to how they're going to track that and maintain that. So with QC QA, that's an agreement between the contractor and the testing lab to put that in the quality control plan as to who's responsible for making sure we keep and maintain temperatures in the initial curing during cold weather at any time throughout the 365, 366 days in a year. For a 455 contract, that is an agreement between the private testing lab and the contractor. They would need to work that out. For a non-QC QA, that would be the contractor's responsibility.
Okay. Do you see a replacement to Compass anytime soon? And if not, what other programs do you prefer?
I won't say that it's a replacement. Compass is still available and still there for use. We do allow for Tyler Lay's tarantula curve to be used. So if you do go out to the World Wide Web and search up Tyler Lay and tarantula curve, you will find a lot of good information and the ability to develop mixed designs using the gradation-based tarantula curve, and we could lead towards going that way. I think there will be a shift to that in a sense, because we will then shift to a gradation-based type situation is my understanding, and may have to do a little more digging again and refresh myself with the tarantula curve, but I think that would be leaning towards doing a full gradation of the coarse and fine aggregate to achieve that, and then the ready mix supplier would need to keep track of that on a weekly basis or every other day, or we'd have to determine a parameter as to how often we need to perform a gradation for the tarantula curve test.
Okay. I got two more questions here. One came in offline. I'll ask that first, then I'll get to the last one that's at the Q&A. Can you explain what the white sheet of paper test is for curing?
The white sheet of paper is not so much a test. I'll kind of pull up a sheet where I've had some writing on, but the white sheet of typing paper is in essence for any inspector, any contractor, any testing lab, anybody that is overseeing concrete production. What we're after is, and I'll kind of cover my camera with what I believe to be a sheet of white typing paper. That is what our concrete should look like when we're applying curing compound. It shouldn't look like I sent my 10-year-old son out there and just said, go ahead and spray it along, and we've got M's and W's running down the side of the wall or on the slab. Or if we're doing a concrete pavement and it's a long concrete pavement, we shouldn't see any gray streaks in the cure cart. So the cure cart should be adjusted such that the fan is spreading enough get a slight overlap such that we're not seeing any excess. I mean, we don't want it pooling up. We don't want any runs or streaks, but we do want a nice consistent application of cure. And I did steal that from Minnesota DOT, so I can't lay claim to that. That came from my counterpart, Maria Maston at MnDOT, and that is her specification. And that is a really good spec. We can take any sheet of white typing paper out of a printer. It can be kept in the truck as long as it doesn't get too dingy and dirty. If so, change it out. But you hold up a sheet of white typing paper next to your concrete, which is gray. After the curing application, if it is still gray, then we have not adequately covered the concrete with the curing compound.
Okay, last question. Are there any new cement/concrete technologies under considerations by ODOT?
Any cement technologies?
Any new cement/concrete technologies under consideration by ODOT?
We've been looking at, I know it's been on the list previously, we've been looking at the CTS rapid set cements. And also we do have the type 1L cements that are available for use as the cement industry continues towards being greener and using a 1L cement. We do have the type 1Ls that can be used. They are on the website. Currently, they are treated as a standard C150 type 1 cement. So it may not be an apples to apples, but we are testing a type 1 cement and a type 1L cement in the same manner. So to address that, and with that, I have been looking at the 701 section where we do have the cementitious products, and the specifications for that is making some spec changes to that to kind of alleviate some of that and clarify some of that language and make it a little bit easier and neater for folks to find. I know we've had some discussions of using type 1L cement for soil cement stabilization, and those discussions are ongoing. I'll say that. But I think we are in need of possibly more research from that side of things for our engineering staff. They are the ones that have had the questions of me. I've asked it and said type 1L versus type 1. Yeah, we got a little bit more limestone in the 1L, but it is in essence the same material. Why can't we use it in a soil cement stabilization situation? So that's where we are with that today. Those are the technologies that we've been looking at. The CTS cements have been around. We've used them in latex bridge deck overlays, but I know they're wanting to possibly use that in our RCM or fast set concrete patching applications as well. And that may be an avenue for that in the future.
All right, Dan, thank you very much. Great presentation by yourself and Dan King. Thank you all for staying on and listening. From Ohio Concrete staff, we just want to say thank you and have a safe and happy Thanksgiving. And we'll see you the first week of December. Thank you.